Okay, it looks like we are live, so welcome back. Today I'm going to be continuing to work on Kano script. So, let's see. In between streams, I worked on a little bit, so I got it working now, right? So it actually runs properly. Kano. It'll work now, again, right? It was working before, but I added an actual symbol table, because before, basically, there's two things, right? We append it to the variables, or whatever, variables, functions, whatever, and that is what we're actually compiling. And I was using that to verify the names of them, but now I have an actual symbol table which stores the reference to all the things, to the variables and things like that. So that's how we can make sure it's valid. Do that. So I'd like to get types actually working now and checking, right? So check, basically any expression, right? It's going to have each part of it is going to have a type. So 12 plus that plus 3.0, right? So each one of these has a type. This is an int, a string, and a float. Stream streak. Oh, shoot, stream streak. That's like a feature or something you get. Channel points or whatever, right? Let's see. I think it's a pretty recently added feature. Right, but each one of these has an associated type, and we have that. That should be working. What we have to make sure is each primary expression within any given expression is the same value, right? Push-ups are now 25. Yeah, I increased it a little bit. Yesterday was a bit much. I had to do 70 push-ups, I think. 60. I had to do 60. That was just a little too much. Okay, let's see. Yeah. So let's go to parse primary. So we return from each one of these now sets a data type. Right, so type int, type float, whatever, based on what it is, based on the value or the type of any identifier, things like that, right? So now what we have to do is we have to check in the parse expert1, actually, it's right here. So we want to look at this, right? So we have new left-hand side, we do that. Make the left-hand side and the right-hand side. So if the right-hand side is ever different than the current type, then we need to do some stuff. So, we might be able to just do it like this, but we might have to check some other places. Right-hand side data type does not equal left-hand side data type. Now, there's going to be a couple instances where this won't necessarily be correct, but I'll just do that for now. Then we will print error. Not sure why it is so indented. Print error with the left-hand side location. I'm going to print question with types of both and that. I don't know if I have a types. I don't know if I had that. I might. Inside data type and types, right hand side data type. Just looking at that, I might not have that. Might not have that array. Types undeclared. Yeah, so we don't have that. We might have that. Do we have that in here though? Data type size and node type. No, okay, we do not. So, I don't wanna, let me look at the types. Right, so these are the types. So you have all of these. I don't care about the count. Let's go to here now. And I would just add it here. Well, I guess we have this. We can use that. We can use the data types, dot data. So we can, that'll work. That will work instead, because they are literal, so they have null termination. So that will be fine, actually. Okay, export one. We can use, these data types, right? Data types. Dot data types. Dot data. Okay, got off a little bit, but that's alright. That compiles now. So it's not going to work, right? With that. Types of both stir and char, right? So that's the thing, right? So characters are different. So where is that at, actually? It does not have a valid location. Why is that? If I use right-hand side location. They should all have valid locations, so I don't know what that's about. Yeah, it doesn't show. So let's see, where would it be? This has a string type. Yeah. So like that's one of the things I was thinking about. So let's go to Kano, right? Let's try it out. Cobra coding. Let's go. Let me try this one. Main Kano. Right, so that has types of both float and stir. Yeah, float and source. Obviously, that's not valid, but if I do +4, that shouldn't be valid either. Like, I don't want that to be valid, right? I want it to be, it has to be the same type or casted, right? That is the idea. Float and int, but if I make this 4.9, then it should work. Yes, okay, and obviously it's float, so it doesn't actually work, but... and let's try maybe 5 plus 4. 5 plus 3. What I meant to type, for sure. Okay, and 8. Alright, so that works. So now they have to be the exact same type. So an instance where, other than that, string one that we had, an instance where you might not want that is basically, if you have a pointer, right? So let's define a pointer here, equals like 3, right? And you want to access whatever element of it, you might want to, actually do h plus 5, right? Something like that. Alright, obviously that's not valid, but h plus 1. Say that, right? And obviously this is going to be a bit problematic. Because you cannot do that, right? So this is going to be invalid. By reference. Space token. Inserted a null terminate character. Space token plus. Actually it might not like that. Yeah, expected an equal. Okay. So we can't actually have just statements like this. We can set that to a pointer equals that, right? We can do that. Yeah, pointer and int. So that's a case where we'd want to check that. Except, I guess if we cast it, then it would work, right? If I do 2bp that, you know, I don't know if that's valid, is it? I want this to be evaluated first. Where's x? Oh, shoot, we don't have x. Okay, we'll get rid of that. So that must work then. Alright, so that works then. So you can do that. Do I want that, right? Instead of, like, implicitly casting it. That might be better. Okay, I'll leave it like that for now. That might be good. So, right, we want to do this every time, though, right? Check it each time. Let me just try that and see what happens, and then I'll actually think about it. Okay, let me see here. So, I'm not sure it matters because we do this, and we just use that as the left-hand side. So yeah, it basically is checked either way. So that's not really necessary because we're calling this function recursively, so it gets checked here. So that's actually fine. Right. Yeah. That works out. So, right. The thing with the character, that is because of the way that I handle strings, which is not necessarily ideal. So I go to, like, a string, right? A string, if we have that here, case, string, data type, should it be a char, right? But it's an array of characters, right? Because if it's an array, then we use that. So, I'm not sure. Right, I think that would fix that problem. Maybe not. Okay. Oh, you know what? It's because it's not a string literal. It is a string array. Okay, let me go to that. Also, we check here, right? We have to make sure that the data type that you define matches up with this, right? Like, a stir is not really a data type. It's really an array of characters. So that's something to consider. Let's see. This is where I want to recall that. After that, if it is array, then we do all this. Where do we set the data type? Actually, I guess that's in parse varday. Yeah, because we set it to set it based on whatever that is. So tokens value dot type, right? Which is a string in that case. Okay. So I think maybe we'll just for now we'll just add that as like an extra one, right? An extra thing, if that makes any sense. Just if that, or right. And inside, and if that, or either one of them is a string and the other one is that. So that actually is kind of a lot of checking, right? Equals type stir, and left hand side the data type equals type char, not char bit, but just type char, or that, or right. So this is not ideal. So we need to actually check the, right, so we need, instead of having a type string, we'll have a type character, and it will be set as an array. But when I implemented the string, I didn't have arrays yet, so that is why I did not do that. Equals type char, and let me that and that and left hand side with equals type star. So I'll just do that for now, and that should allow that to compile, right? If I did it correctly. Stir and char, really? So it still does that. Because that's type stir and char. So if right hand side equals type, oh shoot, I just checked the same thing twice. Left hand side, right hand side, there we go. It doesn't work. Both stir and char. Okay, it's because we're checking this or either of these. Okay. So let's do right hand side data type equals type stir, or left hand side type stir. Then you want to do that. So if either of those are stir, okay, I don't really like this. So maybe I will just try to actually get it working properly. Let's get rid of that. So we'll go back to this, right? We have that here. Build it. And then, right, so then we can, let's just actually fix strings. So when we're parsing it, we set it to that. So parse var back. So I want it to be is an array, or just type stir. So if node value var type equals type stir, then set node value var type equal to type char, right? Because then it is already an array. And this is going to cause some other issues, probably in other places, but that should allow this to work. Wait, that but found integer. Okay. Why is that? Okay. So just changing this broke that. That is incorrect. Let me go back here. I just want to try this again. So let me just say if that right, so if it is a string, then I just want to skip over it. And right hand side, it's not type string. And right hand side, it's not equal type. So if I do it on stir, just skip over that. Alright, both of those. Int and char. So where is that? Is it this? Data I. Well, data is an int, so that's not it. Those equal that, and that is a character, so that should be fine. There might be somewhere where we are doing that and we want to cast it. Okay. I don't get why the location is not working though, so let me look at that. Where do we set the location? Shoot, did we not set it yet? Parse primary. Well, that should return a location. Oh, did we not set the location? Hang on. Expert. Where is the expert? So we allocate it. Let's set for location equals token. We do have a token, so we can just use that. And that should be fine. Like anything's better than nothing, right? And make it better later. Still doesn't work though. That location equals that. Right. I just stopped setting it in some places, but it should still be fine. So why do we not? Okay. Okay, no. Okay. Yeah, I want to do this, and let's do x int equals 3 plus 5, and that should fail. Wait, I can insert a null byte again. Yeah, so that's right. That gives a location. Okay. So why would it sometimes not? Do we do something wrong? Expert equals parse expert. Right. That should be it. I imagine. Zoom tokens. Type, and then let's also set expert location with token out location. Let me try that. Because there might be something with that. But I want to know why this is not. Let me look it up. Let's see. Run. Oh, that can't. So then we'll see where it ends at, right? That actually doesn't show, but it ends there, so we know where it ends. So let's break on parse right? And then run. Oh, whoops, I spelled it wrong. Right. Then run. There we go. And let's see. So let's look. Token, which has its v. Token type none. Location equals that. Wait, token type. What is the type? It's none. Why is it none? Oh, it's int. Okay, because we hadn't defined it yet. Yeah, that makes sense. Okay, so that file name is that. Let's see, built in that. So this is an integer. Set is fine. What's the value as an int? 32. Okay. Oops. Export dot location is that, so that's fine. Right. Then we'll continue the next one. Token dot lot. So that has a proper location. Export out location. Okay. So that's not good. So it's the second one. It's already broken. So let's run it again. And we'll continue. And next. So token dot location. And we have that. Print export out location. That and export out location. And then it's set. Okay. Then we go in here. Export out location is currently that. Maybe that export out location, and it gets reset from this. So this, I guess, clears it. Okay. Yes. So we need to basically set them all individually, or just set the types. Let's just say it before we return it. Then we'll say export location equals token out location. That should fix most of them. Some of them might return early. Not sure. Let's see. Return export. That right there does. So we need to set there. Export location equals token dot location. All right, and I think that might have been the only one. So then we can get rid of this, right? Because it'll be set by all the other ones. Main. Okay, there we go. No, okay, no. So 46. Okay, data. Ooh, okay. Yeah, I see what it is. This makes sense. So we're using this and a character. So let's just use 48. Right, because that's the same thing. Yeah, so we don't really have casting at the moment, so we can't just cast that. But obviously that would be helpful to do. And then it does work. Okay, so we get no type issues. So that is good. I'm assuming it worked, like it actually worked. But yeah, that makes sense. So basically, what we can do to fix that is add casting, right? So just basically, like we can cast to a void pointer, we can't cast anything else. So we'd have like 2 char or whatever, or 2 int, and then put that in there. And we just look at the type, and that is how we would know what it is, basically, right? We can't do that at the moment. And actually, we'll probably wrap like this. Whoops. Right, and then that would be valid. So I want to make sure. I want to make sure that all of the expressions are the same type. So that would return that type, right? But for now, I can just do this. And that will work. So that is good. And then Kano, Kano. So that fails. Rayleigh 5.0 has closed source Nintendo Switch support. Really? Closed source? How does that work? Nintendo Switch. I know that you can make stuff with it, but I didn't know it was closed source. Closed source. Is this? So that's not it. That's not an official one, right? Alright, so I guess that is it. That is interesting though. Yeah. Because this isn't an official one, it's a fork, but... okay, right here, let's see. There we go. Read the patch notes. Remember the push-up queue? I did all of them. I did all of the push-ups. Did them all last night. Hand. Switch. Okay. Ooh, Nintendo Switch. Okay. Backend was quite a challenge. Adding support for that. It's finally trying to add support for the Nintendo Switch. Right, so it uses the closed source API, right? Didn't actually mean you had to do them. Well, yeah, I was happy to do them. It's funny. I did raise the price though, because, or you know, the price of layers of abstraction. Yeah. So now it's just a little bit more. Classic Nintendo. That is interesting though. So I wonder how it, like, is it just using the API? I'm assuming that's what it's doing, right? Because I know, like, I haven't looked at Nintendo Switch specifically, but I've looked at, like, stuff for other game consoles, and usually they provide, like, a development kit, right? So how does that work? I want to look at that. Have you also switched from Awesome Wonderman? Nope, that is what I'm using currently. Raid Live Stream? I have done some of those, but I would like to do some more. Title bar is not awesome. Why not? I like to also do like OpenGL, right? So much lower level, and then try to sort of implement my own Raylib. Not exactly, obviously, but similar idea behind it. But yeah, Raylib is very cool. I want to look at this though. How can I find it? Rcore Switch. Oh, that's probably in here then. Learn OpenGL. It is not like Awesome Wonderman. Well, it is. I haven't changed it. No. No, I thought over. Dr. Column. Yeah, there we go. Yeah. I've not changed it. No. So I don't know why it would be different. Yeah, okay. Why read? Alright. Welcome. Yeah, I should definitely read through this, because I definitely want to look at that. That could be a fun thing. Do we have the graphics? Yes. Graphics are confusing. And I never really went too deep in them, but I want to. I want to make, like, I guess just, like, a game or something. It's not fun. Well, it's not fun, but it's also fun. You know what I'm saying? Okay. Very interesting. Interesting stuff. Okay, stream should be back now. I think it went out for a second there. Should be good now. Should be good. Hopefully. Let me make sure. Doesn't seem to load for me. Okay. Yeah, it should be good now. Okay. Sorry about that. Went out for a second. Alright. Let's see. I mean LS. Okay. Let's see. So that, yeah, so that fails. That is good. We don't have casting, right? So casting is going to be next on the list. to cast any type, right? So you could do to char, to float, or to int, right? Something like that. And that, yeah, that would obviously be good. But now, we cannot do that though. Let's see. So is that good, right? We also need to check that the type of the expression corresponds to the type of the variable, right? Like, so you don't want to set something like, well, some things can be pointers, right? Like if it's a struct, then it can be a pointer. Because that's what all the structs are, they're pointers. Right, and if you allocate it, there might be times where you want to use a void pointer as that. But for for most things, you just want to use the built-in type. So let's go to what we call variable. And let's see, so we call that, and then where do we parse the expression? So we append it somewhere. Alright, right here. So we do that. And that is for each one of them, but that's an array. And that's where this failed actually. So I got that, but basically. Okay, let me look at this. So if I do something like that and then I put a string in here, it's actually gonna. Okay, that does work. Alright. But tried Unreal Engine, so I had to do Windows as well. Unreal Engine, that's on Linux too, isn't it? Is it only Windows? Alright, let's go to just the regular one. So here, we do this, right? So this is called this function, but that's kind of depreciated function, so I'll get rid of that. Nah? Oh, okay, I thought it was. Basically what I want to do is we append that, and then I want to make sure that the node value.var value does not equal the type of this. You can use Lutris or whatever it's called. Oh yeah, really? I thought there was an official one. I mean, I trust you, but yeah. We have a problem to switch to Windows for Unreal Engine. We have to use Windows, right? How do I download it? Good. You have to get it on like Epic Games. Yeah, okay, and I guess Epic Games is only for Windows, so I guess that makes sense. Huh. Equal what? Node value var dot type. Then error. Expression is not match the type of the var. Unindent a little. Arg node value var value. Var name. There we go. Windows for programming. Kind of cringe, not gonna lie. That didn't work. Is that not a... Oh shit, I did not provide the application. Experts has none of that. So... oh yeah, we have to get the data 0. Data. Alright, let's see that. Okay, and what I want to do is try to set it to something like that. So it's not nicely there. Okay, and then if I do 15, so then it does work. Okay, let's try to run it on here. Of the var curve at that location. Okay. Okay, no. The current stir, yeah. Okay, because that's a pointer. So if it's a string, yeah, we just want like it's a pointer, right? Right. So strings cause some problems, you know. Basically, it's just a pointer is what we are expecting here, and that is the type this. This returns a void pointer. But it's like, why is it not a string? So type equal type stir. So if I do that for now, right? So I was kind of bypass the stir stuff until I get better handling of pointers. Then it does work. Okay. What are you making? I'm working on a scripting language. Here is the link in case you're interested. Basically, I built a virtual machine, which has its own bytecode and stuff like that, and it iterates over the instructions. And then I have this language which compiles to the bytecode of the virtual machine, which can then be emulated from there. Yeah, so it's kind of an example of it is something like this, right? So it doesn't have very good highlighting at the moment, but you can declare a variable here. So this variable is called data size. Is of type int, so it is statically typed, and then set the value, of course. And then this is an array, how you would set that. This is data size, so it's, that's the size for the array, and then it allocates it 0 allocated, and then sets the size, right? And this is basically a rule 110 implementation. So if you run it, it would look like this. This is the output of it, and you can change stuff about it as well. So if you want it to be smaller, you could do something like that, and then run it, and now it's small, right? Things like that. But yeah, we have functions which look like this. So these are the args of it. Here's the return type here. We use end and things like that. Keywords similar to something like Lua, if you're familiar with that. Yeah, but this is pretty much what the language looks like. Here's a while loop. Here's an if statement. Early returns. Variable iteration, right? Things like that. And there's also a yeah. This is kind of a long thing because of a limitation in the language. Tree sitter plugin for this. Probably eventually. I want to get it more stable first though, because it's still like very early in development. But yeah, we have modulus operator as well. And just now I'm working on type checking for the language, right? So if we have something like this, so if we have this variable which we're declaring as an integer, and we try to have in the expression a float, then it will fail, right? It would say, especially when types of both int and float. Why is it like that, though? Hang on, let me hang on. Yeah, I included an extra new line. That's why it looks like that. Okay. If I get rid of that, it will not be like that. There we go. Now it is more clear. So here is the file that it's in, here is the line number, and there's the column number. Error expression with types, so it knows the types of both. But if we change it so it is both integers, then it will work. Or if we try to do something like set it to a float, even though it's a type of integer, there's no implicit casting or anything like that. Yeah, so it will say this. And also that does not work. Yeah, so I included a new line here, and that is why it does that. And now it does not. Okay. Yeah, so things like that. That is basically the gist of it at the moment. So that is invalid. Cool. Alright, so that works pretty well. I think I will commit it. Committee. Like basic type check for both variable declarations and for each primary within an expression. Okay, push that. Alright. So that's mostly what I wanted to work on already today. It's been about 30 minutes. It says 10 minutes, but that is because the stream went out. So now I will, let's see, so let me go to the string thing. So, we go here, actually parse. Okay, let me character, well that's not exactly right. So that's a bit complicated, so I'll get rid of that. What I want to do, let's see. I'd like to soon, it's basically two things that I would like to work on, right? So I want, I have a preprocessor already. It's not very good, it needs a lot of work. Let's see, tip.h, titanium preprocessor, right? I'd like to bring this in so that we can call that on it. So we can do things like import. Let's see. Right, something like that, not test. Let's just do second.kano, right? You can import that. That is how you would import it, and we'll basically just expand the file at the top here. So you can have libraries, so you can have standard.kano and have build out the standard library, and that would be obviously useful for obvious reasons. It might be a bit limiting considering it's like a separate thing from the compiler. So in the future there might be different ways to import them, but this is something that would be fairly easy to implement. And then you can also define macros like def x is 10, things like that. And then you can use x. Yeah, and I forget what else I can do actually. Let me look. There we go, right here. Yeah, what else does it have? Do I have? Alright, so that's all it is. Yeah, you can import and you can define. It does have some issues, so I'm pretty sure it, has some memory leaks and stuff. And some other problems like that. Because I did not really know what I was doing when I wrote it, but it does work. So yeah, it just needs a little cleaning up. Is it fast? Is what fast? The preprocessor? I can test how fast that is. So let's go. The language. Oh, okay. So language itself. Well, here. So I have actually. Shoot, I got rid of it. So I can time it, right? Okay. Time it. This is a little unfair, but yeah, it's about 20 seconds. So that compiles it and interprets this, right? We'll know. But if I actually compile it first, the compilation time. That does not take long at all. What the heck? Okay, so I guess running it actually takes by far the most time. And then we look at this. 17. Time. Ooh, no, 10. If I do that, and I time that. So I guess that is pretty much all of the time, is that. So the compilation takes no time at all. That is kind of surprising, actually. Does it have recursion? Yes, actually, you can use some recursion. But I just wanted to finish thought with this very quick. So I did test it compared to Python, and it was faster. It was faster than Python. So, I'm not very good at Python, so I might have made some mistakes. But just like a quick implementation of the same program in Python, it was faster. So, yeah, and then C, it was about 10 times slower than C. So, but it was just a very simple program, so it's not really a fair comparison. But let's see. So recursion, so you can do something like return void, and I can test it. I just want to make sure it does work. Python equal JavaScript. Not exactly. Let's do x minus 1, and then if x equals 0, then and we will just exit with 69, right? So if we call foo on 10, right? So it should go through a couple iterations. Let me try, make sure that works. Yeah, okay, I forgot to get rid of that. It did exit 69, so I'm assuming it worked. Let's see, but I can try it, right? So maybe I will have a secondary variable. Maybe a little bit better. Yeah, I think Python is a little better. Like, at least, Python, it's not statically typed. It is dynamically typed, but it is also strongly typed. So you can't, right, there's a lot of things that it prevents you from doing that JavaScript would not. And then we just have 0 there. And perhaps we will do, y equals y plus 15. Exit of y. And let's actually change this. So this is the number of iterations. So 3, so that should be 45. What? Damn, I messed something up bad. Oh yeah, right here. And 60. That is not like, what? Oh, you know what? Because it goes through more than that. Because it goes here, right? It doesn't want. So yeah, I actually did a stupid. I put it in here though. 45. Yeah. So yeah, recursion does work. You can see that. There might be some more complicated things that it actually fails on. But at least basic recursion does work. Always make that order mistake. Yeah. It was pretty easy to just kind of accidentally do. But that does work. So that is very cool. Yeah, when it says it one more time. Yeah, yeah. Always gotta check the exit condition first, right? Let's see. So this should also, I don't know if we checked this. we definitely do. So that is gonna, yeah, it just does a stack overflow because this is a pointer. So that is interesting actually. But if I do x plus x minus 1, and I set this to the pointer, what's it gonna look like? Stack over. Yeah, okay, so it still overflows. Yeah, the stack, it does have a limit, I think, of 1024 items at the moment. I need to obviously make it larger than that, but that is what it is for now. So when a pointer is that large, it has to go pretty far, right? We can even look at the pointer, but I don't want to do that. Let's see. Base there, yes. Something that's a problem though is that you can't really give any information on the file because the virtual machine itself does not have information about what the file is. So I'd like to try to make it so that it is extremely hard to have runtime errors like that. Because obviously that can make it a bit difficult to debug. I can give more information though. I don't really give much information, but you know. Yeah, so I do want to check that. So let me go to yeah, we need to check each of those. So we can't really check that though. It's kind of hard. Well, we can, but it is harder. So function call. That is a different place. Hang on. Yeah, so here we do all of that and we append that to the arg, but we need to check the data type of both of them. Alright, so instead of this, I want to check the data type, right? So if arg data type is not equal, right? So data type that is not equal to node value call that args data. I get to do this whole thing. Basically gets the current location of it. Node value. Oh, let's just get what is that though? Watch this .args .count minus 1. So you have to do that. I still don't have the count yet. So it is goes here. And so that's just this argument. So actually that is incorrect. So I want to compare it not to the argument, but what is it? So the argument expected data type. Which is what? So we need to get the function. Let's do get function. And you also need a function name. So we'll do node value call that name, right? Then we'll have the function, which we actually want to get it up here. That makes a lot of sense. Okay, so we'll get it there. And then we need to compare it to that. So we'll look at this, but we need let's create an iterator here, right? So this is the our index equals 0. So the first one's gonna be 0 and so on, right? And we'll do plus plus here. Does not equal function args dot data arg index dot value dot var dot type. I think that might be right. Okay. So we'll use the arg location. It will say data argument view print. Whoops, view print data type does not match. Does not match expected data. Right? For function reprint. Okay. Let me it's here. Go like that so I can see it all. And then we need to use the argument. Arg, we had 2 of those. It's gonna be a new line. View arg, so this is data arg index value .var. So I should make a variable for this, but I'll use this for now. And then view arg. What is the other one? For function? Yeah, so function name. Alright, that should work. If I did everything correctly, which I probably don't. Okay, get function, that's what it's called. Function. Arg is a pointer, right? too few arguments, so that expects location. Yeah, we can pass location as well. So we can use node location. That expects the function. This needs to be parser function. Okay, and now argument x data type does not match expected data type for function 3. Okay. Yeah, so maybe I should change that message. So it should maybe be something like expected argument that expected data type x but found y. Expected data type that but found that. Yeah, I think that makes more sense. Yeah, I don't think we need that. So let's do this. So we still need this for the first one. But then we need the data type. So data type. Data types are the data type. No, so that is not the expected one. This will be the expected. Args dot data arg index dot value dot bar dot type. Okay, dot data. This is dot data as well. And there we go. Let's make type of input and char. Okay, yeah, because that is well, it's a character array. So that's fine. And then if I put an actual character in it, I say the same thing. So I type int, and if I put a float here, say the same thing. Float, and if I put the correct thing, it actually works. Okay. Very nice. That is better now. I'm gonna close this properly like that. There we go. Is that better? Maybe it should be more like this. I want them all to be the same. Yeah, maybe that's better. I know I was kind of not sure what I like better with that. Also the highlighting. It's a little messed up. But let's see. So I will commit this. And type checking for function args. Okay. So maybe I will create a variable for this now, so I don't have to do that each time. So we'll set the current arg. Current arg equal, well, it used to be a variable. So variable current arg equals arg.data arg index arg.bar. We can just use current arg. Arg.name current arg.type, and then we can also use it in here. Arg.type. Okay. Whoops. Whoops, that's the wrong place. I meant to do, script. And okay, there we go. That works. And 34. Okay, where's that? Alright. Looking good. Yeah, I don't know what the deal with this is. It just gets messed up sometimes, that's fine. Oh yeah, we don't need this either. So I can just get rid of that extra type check function because it is outdated and not used. Get rid of it entirely. Okay, and let's see. So now I do call it in. Oh, there a bunch of times. Yeah. Okay. Yes, and that works. Alright. Yeah, basically, yeah, that was before I implemented the types properly. So, I can do that as well. Remove type check. Doesn't let me do that. Shoot. And now it doesn't know. It's fine. I forgot that you can't put those in the commit message. Okay, okay. Mm, so this. Maybe I should set the location for this as well. What's left hand side? Location. That should not fail, right? Sure. Okay. That's probably a good idea. Good idea. Yeah, because we need the location for the outer thing. Alright. Alright. So, quite nice, quite nice. Expert types, what is this? Bin, int, stir. Yeah, okay, so that is the different type. What is... Function is an expression type. What? Ooh, if it's like a function call, okay. That is interesting. Okay, yeah, I don't remember all this stuff. I've learned a lot since I initially wrote this, so some things are a little outdated. And they should be looking not necessarily in the structs, but instead in the symbol table, so I need to update that. You update it. Update to use symbol table. Proper symbol table. And then also, this function I think has the same issue. What? Is that not defined in here? Hello, Eternal Divine Fox. How are you doing? What is up? Oh, it's get function. Yeah, yeah. Yeah, because that's the same thing. So I need to do that. Pretty well. Couldn't sleep, so here I am. Well, what time is it for you? It's not very late for me, but I understand that time zones can vary quite widely. Location, yeah, so I don't need to set this here, because it gets set. Alright, that's good. One at night. Dang. Okay. Yeah, it's only 7 p.m. for me. I guess you can tell that from that. I guess you can't see it, can you? Shoot. Now you can. Gotta change that. Yeah, I changed it yesterday. Let's see. So all that state genet. Maybe I could update this as well to work better. So instead, use a struct. Well, I need really struct literals before I want to do that. Probably. That's probably a good idea. Making structured language, meaning you're making a lexer, parser, and runtime. Well, so I have a lexer. It's not really like it. Let me take a step back quickly. So I have a virtual machine, right, which has its own bytecode, which it emulates. That's essentially the runtime, which already is. I made that quite a while ago, and now I just update it as necessary. So what I'm building now, it's basically a compiler to that bytecode. So similar to something like Java, which has a bytecode, right. So basically, it compiles to that. So I can show sort of what that looks like. So if I run, this is the executable, and I compile it on this this program, then it will compile it into world1.10 here. Here to that, and then I can emulate that using the virtual machine, just like that. But it's also built in, right? So you can also just run the executable like this, and it will run it. It will compile it and run it. So I'm not really making the runtime, basically, is what I'm saying. Making the lexer, parser, and code generation. But instead of targeting native machine code, it targets bytecode. Yes. Actually, I did want to check that though. So there, and I want to run this on, just say this. And what is the time here? How long does that take? It doesn't take too long. Build a few Lexer's parsers in the past. Nice. And how's that gone? Did you use C or a different language or combination of languages? Multiple languages. All right, all right. And have you made like languages for it, or you've just built the Lexer parser parts? Like, have you built the runtime or compilation stage? TypeScript, C, C Sharp, and Python. All right, all right. And how do they compare? Like, specifically for the stack? Because I know, like, at least from what I haven't really personally tried this, but from what I've heard, like something like Rust or OCaml, one of those ones that has pattern matching, is actually pretty good for Lexing. Obviously, that's not one of those, but that was just what I was saying. So I was wondering how those languages that you've mentioned compare. Like if they have specific features that help a lot. SQL engine built in C Sharp. Nice, nice. Very cool. Instruct. It is a struct, and that's the type. Right. Forgot to mention PHP. Ooh. That is interesting. So how does that go? I've never actually used PHP. I have used all the other ones that you mentioned there. Well, I haven't really used TypeScript, but I've used JavaScript. But yeah, C, C Sharp, and Python, I have used those. Quite a bit actually. But yeah, PHP, I've never even really looked at PHP code for very long. PHP 8 is pretty fast, really. PHP, is that the most modern version? PHP, 2021. 8.3, okay, so that's where we're at. 8.3. Uh-huh. Kind of light mode right now. Speed, I want to look at that. So how fast is it? Okay, so it has a JIT compiler, that makes sense. Let's see. Alright. Written in C, okay. Yeah, alright. Interesting. So they didn't have a JIT before that? Streaming slash event-based parser, which using an observer slash server event with reading token statement from a file with seekable file stream. Okay. Do you have a GitHub link to that or something like that? If you want to share. It sounds quite interesting. Just time compiler. So they didn't have that before. Let's see. We're saying compilation, and yeah. So in memory, not storing all lines and tokens slash statement in memory, right? That, right. Compilation opcodes are interpreted, yeah. ZenVM, ooh, is that what PHP uses? Yeah, I don't know anything about PHP, like I said, so. Is VM on a LAN machine? Don't use Git to save project just yet. Okay. Alright, all good. What is this, though? Is this it? Is this the whole thing? Is this one file? Holy balls. Oh no, there's a whole bunch of other stuff here. Okay. Zen engine. Zen compiler, executor. PHP source code is rather large. Yeah, that makes sense. Given how well, not necessarily it's that old, but still, pretty much anything that's from 1999 that is still used today, it's going to be pretty large. Let's see, yeah. Into memory and compile it into Zen opcodes. Right, I don't know what opcode is. Okay. HTML generated is sent to the client, huh? Most website, yeah, for sure. Like WordPress. WordPress is entirely PHP, right? And that powers quite a few websites. Okay, let's see. Interesting. This could work like struct. Well, I could use get struct as well. Like get volume. Look at that. Right, so I return that. It should probably return just a pointer. That would make a lot of sense, actually. GraphQL engine in TypeScript. Ooh, okay. Interesting. Query language for APIs, right. I've not used it, but I do know what it is. TypeScript is interesting. How do you like TypeScript? Usually I'm not a big fan of that kind of stuff, but, you know. Query language for APIs, right. Yeah, okay. Yeah, I haven't used it. I don't really do any web development kind of stuff. Okay, that's interesting, actually. Right. What do you think of like what is it? It's like JSDoc, right? I think that's what it's called. We use comment. If I understand correctly, I might misunderstand because I haven't tried it. We use comments to say the types of each thing, and then it will complain if you do not do that. Like you run that over it or whatever. You don't have to use GraphQL in web dev. Yeah. I'm not saying that you do. I'm saying, you know, usually it's for web dev, right? Or something like that, right? And I don't do things like that. Like I don't use things that use called APIs or anything like that. is this? What does it stop? Okay. Right. So, I have returned to a point here. This one probably should as well. Get the function. Check ours. Okay. That is fine. Mm. Okay. Yeah. That works. Let me actually. I want to try. Try some of these. Alright, that's the worst. Strength repair. Store range work as well. Hopefully that's not like that does. And then, of course, risk is the other one's called to it as well. Alright, so all that works with the type check. Right, yeah, so you can't do this. Update that. Okay, cool. No test. Here's more of an example. I don't have a test thing yet. Anyway. Alright, yeah, that's probably gonna be pretty much about it. Yeah, so the next one, next stream. Next thing plan, I guess, probably would be a good idea to implement the preprocessor, like I was talking about earlier, if you were here. Let's see. Yeah, so I have this preprocessor, right, which can do things. So if we look at, say, a text, I have a lot of text here, they're kind of not very good. That's not text, right? So you have this. So you can find that, you can import other files, and then, yeah, so it's basically imported files or defining constants. So test, if I do that, then it switches to this, and this is like the line number and things like that. And so I'd have to update the lexing and how we handle line numbers and stuff like that. But, yeah, just line numbers, because the columns are the same. So, yeah, that shouldn't be too hard to implement, and then I'll be able to start building out, like, a standard library and things like that, and that would be pretty fun. But yeah, other than that, actually I do want to look at this, just really quick, before I end. I want to try running Galgam, seeing, like, what all the areas that we have. Because it's going to be a lot. Can I redirect this into... Let me look. So, yeah, there we go. I'm gonna read, yeah. How long is it? 3:38, yeah, it's pretty long. So I'll probably go through these. Maybe on stream, maybe off stream. I'm not sure. But yeah, I want to implement this because that would be very cool. Very cool to do. Whoops. Alright, and that does not fail, that's good. Not the outlet, does it? Still work. Right, because it should free it at the end still, so yeah. Alright. But it doesn't free it during the runtime, so it still could have a memory. Okay, so that all works. Yeah, so that's gonna be about it. So thank you guys for watching, and I'll see you next time. Bye.